Hi guys, welcome back to another video of Chemistry 101. This is part 2 of chapter 3 methods of purification. In the last part we talked about what is a pure substance and what are the different techniques used to separate a substance from a mixture. In this part we're going to be talking about paper chromatography and testing for purity of a substance, beginning with paper chromatography. Now, paper chromatography is a technique used to separate and identify components of a mixture and is also used for testing of purity of a substance. Now, let us look how we perform paper chromatography. Now, here is the setup used for the paper chromatography. There is a chromatogram, which is the chromatography paper, which is dipped inside a solvent, and the baseline on which dyes are placed is just above the solvent level, and on top there is a solvent front, which is basically the maximum distance traveled by the solvent. The principle is the solubility of these components in the solvent. The more uh, a component is soluble in the solvent, more it will move on the paper, and a mixture will produce more than one spots on the paper, as it is made up of a collection of components. Now we can here see that dye 3 is more soluble than dye 2, which is more soluble than dye 1, and if the two substances are have the same solubility, we say that they are the same thing. For example, over here dye 1 has moved a distance, and the one component of that mixture is also moved the same distance, as you can see. So we can say that dye 1 is present in the mixture, and one component of the mixture has moved the same distance as that of dye 3, so we say that dye 3 is also present in the mixture. So we hereby can say that a mixture is basically this mixture basically made up of dye 3 and dye 1. Dye 2 is not present in the mixture. One term which is used is called RF value. Now, RF value basically tells you about the solubility of that component or that dye or that substance inside the solvent. The higher the RF value, the more it is soluble. RF value is calculated by dividing the distance traveled by the spot on the chromatogram with the distance traveled by solvent, which is basically the distance of baseline and solvent front. If the two substances have the same RF value, we say that they are the same thing. Now, if a substance is colorless, uh, we cannot see the spots on the chromatogram. For that, we use something which is called the locating agent. Now, what a locating agent does is it basically reacts with makes it colored. So we can see the spots on the chromatogram. For example, a very famous uh, locating agent is ninhydrin, which is used for amino acids, which are the building blocks of a protein. Now, this ninhydrin, when sprayed onto the amino acids, it makes it visible for us and helps us to see the spots. Now, one other important thing is that you must draw this baseline with pencil and not with colored ink, because with ink pen, because if you draw it with ink pen, the ink can spread over the chromatogram, so we don't want that. So we draw this baseline with pencil, and the position of this baseline is just above the solvent level. Now this is for the chromatography, and now let's move on to the next topic, which is the testing of purity of a substance. Now, One thing which a pure substance will always have, it will always melt on a fixed temperature. So this can be a testing for a pure substance that it will melt on an exact melting point. For example, if pure stearic acid melts at 70 degrees Celsius, if it is pure, it will melt at 70 degrees Celsius. If it melts a temperature lower than that, it means that impurities are present. So we can also say that impurities basically lower the melting point, and it also makes that substance, if a substance is impure, it will melt at a range of temperature. Now another thing is that uh, pure liquid will have a fixed boiling point. For example, ethanol, and if ethanol is pure, it will boil exactly at 78 degrees Celsius. If an impurity is added, it will actually increase its boiling point, and it basically makes it not be boiled on the fixed temperature but on a range of temperatures, which is very similar to that in the case of melting. And another thing is chromatography. Now here we have a mixture in three dyes. Now if you see that the mixture has made two spots and each of the dye has made only one spot, so we can say that these dyes are pure because a pure substance always forms one spot on the chromatogram. Now this is especially useful for the substance which cannot be easily melted or distilled. So that was it for today. We'll be beginning with the next chapter in the next video. Until then, goodbye. Thanks for watching.